Welcome to the spoken tutorial on arrays. In this tutorial, we are going to learn how to declare array variables, how to construct arrays, how to use for and while loops, and how to use OM shell. To record this tutorial, I am using Open Modelica 1.9.2. You may use any of the following operating systems to practice this tutorial. To understand and practice this tutorial, you need knowledge of arrays in any programming language. You need to know how to define a class in Modelica. Prerequisite tutorials are mentioned on our website. Please go through them. Vector is a one-dimensional array. It has single index. Syntax for vector declaration is as shown. The example shown declares a vector variable a whose size is 2. A vector can be constructed by including the elements in curly braces. This example defines a vector parameter a with 2 and 3 as its elements. To access the elements of a vector, it is necessary to understand indexing. Syntax for vector indexing is as shown. Vector indexing starts from 1 and indices must be integers. Let us develop a function named polynomial evaluator using vectors. This function is an extension of polynomial evaluator function which was discussed in previous tutorials. We shall replace parameters a, b and c of polynomial evaluator with a vector a. Please download and save all the files available on our code files link. For your convenience, polynomial evaluator function is also made available. Now let me switch to OMEdit to demonstrate this function. OMEdit is now open in welcome perspective. I have opened all the necessary files. Note that the following classes or functions are now open in OMEdit: function tester, matrix adder, polynomial evaluator, and polynomial evaluator using vectors. Now, to view them, let me double click on each icon. Let me shift the OMEdit window to the left for better visibility. Go to Polynomial Evaluator tab. Open it in text view. For more information on this function, refer to the previous tutorials. Let me go to Polynomial Evaluator using vectors. Open it in text view. Input and output variables are the same as in Polynomial Evaluator function. Parameters a, b and c of polynomial evaluator are replaced with a vector a. Size of this vector is 3. The elements of this vector are included in curly braces as shown. The elements are separated by a comma. In the assignment statement, the elements of vector a are accessed using their indices. A1 is the first element of vector a. Similarly, the second element and third element of vector a have been accessed as well. Now let me switch to function tester tab. Open it in text view. This class is similar to the function tester class discussed in previous tutorials. Z is a real variable. Polynomial evaluator using vectors function is called with an input argument of 10 units. The value returned by this function is equated to Z. Now let me simulate this class. Click on Simulate button. Close the pop-up window. Select Z in the variables browser. Note that the value of Z is equal to f of x at x equals 10. This plot is the same as observed in the case of polynomial evaluator function. Now let me deselect Z and delete the result. Go back to modeling perspective. Now let me switch to the slides. For loop is used to iterate statements a given number of times. It can be used in algorithm and equation sections. Syntax for loop is as shown with an example. To demonstrate how to use for loop, let me go back to OMEdit. Click on Polynomial Evaluator using Vectors tab. In the assignment statement for fx, we are accessing the elements of vector A. This can also be done using a for loop. Now let us see how to include a for loop in the algorithm section. Firstly, comment the assignment statement for fx by inserting double slash at the beginning and end. Save this function by pressing Ctrl+S. The for loop to be inserted has been provided in a text file named forloop.txt. It is available on our website. I have opened this file using gedit. Windows users may use Notepad or any other text editor to open it. Let me go to gedit, copy all the statements by pressing Ctrl+C. Go back to OMEdit, press enter, paste all the statements by pressing Ctrl+V. Save this function by pressing Ctrl+S. Now let me explain each statement of this loop. This statement assigns fx an initial value of 0 before the loop starts. Here I serves as a loop counter. The loop runs until value of I is 3. It is not necessary to declare I before it is used. Let me scroll down a bit. This statement iteratively adds terms of the polynomial f of x. Polynomial f of x has been discussed while discussing polynomial evaluator function. This statement indicates the end of for loop. Now this function is complete. To test this function, let us use the class function tester. I have made no changes to this function. To this class, let me simulate this class by pressing Simulate button in the toolbar. Select Z in the variables browser. Note that the value of Z remains the same after changes are made to the function. Let me deselect Z and delete the result. Go back to modeling perspective. Now let me go back to the slides once again. While loop is used to iterate statements until a given condition is satisfied. While loop cannot be used in equation section. For loop is more frequently used in Modelica as compared to while. Let us discuss arrays now. Arrays are used to represent multi-dimensional data. They can be constructed using vector notation. Syntax for array declaration and indexing is as shown. To understand more about array construction and indexing, let us write a class named matrix adder which adds my matrix and adder matrices to give MySum. My matrix and adder matrices are as shown. Now let me switch to OMEdit to demonstrate matrix adder class. It is already open in OMEdit. Click on matrix adder tab. Open it in text view. My matrix is a real parameter array. Numbers in square bracket represent size of this array. The size of first dimension is 3. Similarly, the size of second dimension is 2. My matrix array is constructed using 3 vectors of 2 elements each. 1, 2 represents the first vector. 3, 4 is the second one. and 5, 6 represents the third vector. Size of each of these vectors is equal to the size of second dimension of this array. Hence, the size of second dimension of my matrix is 2. The number of vectors is equal to the size of first dimension. Hence, the size of first dimension is equal to 3. Adder matrix is constructed in a similar fashion. To add these two arrays or matrices, we need to access elements from 2 dimensions. Hence, a nested for loop is required. This for loop runs through the first dimension. Similarly, this for loop runs through the second dimension. Let me scroll down a bit. Corresponding elements of my matrix and adder matrices are added to yield my sum. These statements represent the end of each for loop. The class is now complete. Let me simulate it by clicking on Simulate button. Close the pop-up window if it appears. Let me expand variables column. Select adder 1 1, my matrix 1 1 and my sum 1 1. Note that adder 1 1 plus my matrix 1 1 gives my sum 1 1, which means that the result is accurate. Let me deselect them and delete the result. Let me go back to the slides. As an assignment, write a function named vector reversal to reverse the order of elements in a vector. Similarly, write a function matrix reversal to reverse the order of elements in each row of a matrix. Write function tester class to test these two functions. This brings us to the end of this tutorial. Please watch the video available at following link. It summarizes the Spoken Tutorial project. We conduct workshops using Spoken Tutorials, give certificates. Please contact us. If you have questions related to this Spoken Tutorial, please visit the following website. We coordinate coding of solved examples of popular books. We give honorarium and certificates to those who do this. Please visit the following website. We help migrate commercial simulator labs to Open Modelica. Please visit the following website for more information. Spoken Tutorial project is funded by NMEICT, MHRD, Government of India. We thank the development team of Open Modelica for their support. Thank you for joining me in this tutorial.